today's presentation, we're going to talk about the RAID technology, and since our main product is ITSAN, I want to kind of relate these two together and see how the effect of a RAID and a disk type and all of that is in an ITSAN environment. Basically, the agenda that for the presentation today, we will talk about what is RAID and what the different RAID levels are. A lot of you already know what it is, but since we have a general audience, some of you might not know, so I'm going to go ahead and repeat that for those who do not know what RAID is and what RAID levels are. We talk a little bit about the storage evolution, and also then get to the main part of the presentation, which is how does the different RAID levels or the disk types. I included the disk types into this equation because it really makes a big difference what kind of a disk you use and what kind of effect does it have in your performance in an ITSAN. So we'll talk about both of those. And then at the end, we will get into the Stonefly company and products, and we will also leave some time for the Q&A. Basically, what RAID is, what RAID stands for is a redundant array of independent disks. Some people call it a redundant array of inexpensive disks, but generally that's what RAID stands for. The idea of a RAID came about a long time ago. I would say it's about 15 years ago. That basically, rather than using individual disks, you combine a bunch of disks into one logical unit, and by doing that, it provides redundancy and higher performance, actually, when you combine a bunch of disks into one RAID group. And there are several different RAID groups, and each one of them provides a different level of performance and different level of redundancy. So you have heard about the hardware RAID or a software RAID. There are different OSs, like in Linux or Windows, even Windows, you can create software RAID. So basically, you get a bunch of disks and create different RAID levels. But our main concentration is talking right now is about hardware RAID, because that's what we use in our product, and that's what most people use. The software RAID does have the same redundancy, but the performance of the software RAID is usually much lower than a hardware RAID, just because of the fact that a lot of the RAID calculation and the parity calculation gets done in an ASIC when you're using a hardware RAID. So in a hardware RAID environment, you basically have a RAID controller. So either that RAID controller can be a HBA inside your ITSAN, that is just a plug-in card with the RAID engine in it, or your ITSAN can have a controller with the RAID chipset hardware in there. So that is kind of a general idea of the hardware RAID, that the RAID engine is inside the ASIC rather than inside the within a software. And basically, you have a RAID controller, and then talks to a bunch of disks, and then it distributes the data among all the disks. So let's start with talking about the different RAID levels. RAID 0. We start with that. What RAID 0 is basically it stripes the data. Assume that you have 4 disks in a RAID 0. You can have more than 4 disks. It does not have to be only 4 disks. You can have, I don't know, any number of disks you want. Basically, the concept is, while you're writing the data, rather than writing the data into one disk sequentially, you stripe the data according to the stripe size. It's always these hardware HBAs or hardware controllers, you can specify actually the stripe size that you want. So, like for example, your stripe size is 64K. So when you're writing the data, you basically write 64K on this one, 64K on the other one, 64K on this, and 64K on the disk 4. And then you just continue writing that. And when you're reading, you're also reading from multiple disks rather than reading from one disk. So that's where the performance comes from. So rather than, because the disks have, in general, the hard disk that we've used, they all have a spindle. So if you have only one disk and you're writing all your data in one disk, you have to just wait for that data to be written until you can start writing the second one. But in a RAID 0 environment, you don't have to. You just write it 64K, go on to the second disk, and just keep writing. So that's where you get the higher performance in a RAID 0. And then if you look at this RAID 0, there is no waste, basically. There is no parity calculation, and you probably heard about the parity calculation in the RAID. There is no waste. So if you have disk 1 is 1 terabyte, your basic, the total capacity of this RAID set will be 4 terabytes. So there is no waste in capacity. But what you lose is redundancy. So since there is no parity disk or a spare disk in this RAID set, if you lose one of these disks, you basically lose access to all of your storage. So that's where the trade-off comes from. RAID 0 gives you higher performance, but there is no redundancy. So a lot of people might opt for that. They say, I don't care. I mean, I want a highest speed. So then they do their backup or something some other ways. Like, for example, in a video editing, the guys want to have the highest speed that they can get, and then they do their backup normally, and then they do their redundancy that way. So again, you get the highest speed with no redundancy in your RAID.